Ya, udah kerekam. Udah kerekam. Oke. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan, salam sejahtera bagi kita semua. Let me introduce myself. My name is Rohana Pranangin. I am a final year student of the Electrical Engineering Study Program at Medan Area University. Okay, I would like to export my defense graduates to the ICAISD 2023 institute, which has given me and my team the opportunity to carry out a presentation today. Okay, I'll just start my presentation today. Smart plant protection technology in hydroponics silly plants based on IoT to prevent crop failure due to pests. Okay, abstract. The design of the smart plant protection system is an IoT-based technology that can assist the community in caring for and monitoring their plants digitally. This tool can also make it easier for the community, especially vegetable farmers, to spray digitally even from a great distance from the garden. The technology grid has been equipped with a camera sensor that function to monitoring the condition of the silly plants in real time and with a core result, with which is partner can monitor silly plants using Android even though partner are far from the silly garden. In this smart protections design, the tool needs include ESP 8266 as a microcontroller ESP 32 cam as a real-time monitoring camera. Two relay as a pesticide palm control and ESC sensor as a digital detector of ppm value of nutrients. These sensors are integrated the microcontrollers so that they can provide data via the Android application. All components are integrated so that this technology is expected to facilitate the work of more modern vegetable farmer. Okay, next, introduction. Silly plants are one of the horticultural commodities that have a fairly high selling value at this time. Silly is one of the plants that is very easily attacked by pests, especially silly plants grow hydroponically. Silly plants are usually attacked by plant pests, namely armor-worm pests. Therefore, this is what makes farmers have to take very extra care to get maximum silly fruit yields. But actually, controlling silly plants directly is not easy to do. Not only the time of spraying pesticide is the benchmark for planning success. Silly tree, but quite extra control must be carved out on the hydroponic silly plants. The impact if the hydroponic silly tree is attacked by pests can cause the silly leaf and fruit to dry so that they can be marketed. Okay. Therefore, farmers have to be even more extra to taking care of these hydroponic silly plants. This is very difficult for most farmers to realize because the silly plants themselves must be monitored regularly and must spray pesticide at least once a day. Technological development are currently changes human life to be more modern and more practical. Of course, one of them is the use of tools that are used for monitoring and controlling silly plants easily and can be controlled anywhere without having to be at the plantation location. Plantation farmer can easily get information about their gardens, especially silly plants in the real time, so that the farmer also know the condition of the garden land and can handle it properly from a long distance. Okay, monitoring the condition of series is one of the most important things to do. The goal is to get maximum silly result. Therefore, the purpose of this activity in monitoring is to find out the population of pests that occurs of silly leaf as well as the ppm value of nutrition contained in silly water feeds must be monitoring regularly because these two things are related to the growth quality of the hydroponic silly plants themselves. Currently, many people in the city of Medan have implemented their own plantation using a hydroponic system to meet the needs of household kitchen. And it is possible that there are people's livelihoods are as hydroponic vegetable farmers. Currently, hydroponic chili cultivation has been widely carried out in urban areas because the practice of chili in the market is quite expensive. It is estimated that the price of chili in 1 kilogram is AJR 100,000 in the market. The chili hydroponic system is a technique that does not require soil as a planting medium. Currently, agricultural land in urban areas, especially in the city of Medan, has decreased significantly due to the many infrastructure development activities in urban areas that have turned agricultural land into residential land and industrial land. With this, farming communities are advised to use the hydroponic method as a solution in overcoming limited land for planting, as well as overcome reduced agricultural land by using unused or empty place in urban areas, such as those that can be applied on roof of house, building walls, terrace, and balconies. Okay, next. Monitoring the condition of hydroponic plants is generally carried out by paying attention to information related to nutrition and the need for pesticides to prevent pests on the silly plants. This information also does not present the real condition of the silly plants physically, so observation and sparing of pesticide must be carried out directly on the silly plants area. This result will create a system for monitoring and controlling the condition of silly plants the real time by sending image data sent via IoT with ESP 32 cam module. Pesticide spray and easy sensor. The image data will be stored in an application so that the condition of the plants can be monitored during the plant's period. This tool is also equipped with an ESP 8266 microcontroller which is used to transfer data from sensor with the IoT concept. IoT itself is a concept that aims to expand the many benefits of internet connectivity that can be connected continuously using a wireless internet network. With the application of IoT in monitoring seed plants, this hydroponic system can make it easier for farmers to do gardening even from a great distance. The performance progress of this system also require a community device that can transmit monitoring results of hydroponic chili with the NFT system in real time and provide action to overcome these problems even from a very long distance. The design of smart plant protection technology itself is a modern technology that can help farmers to monitor and control plants, especially NFT hydroponic plants in real time. The advantage of this tool is that it can be controlled easily even though it is very far from the plant. And the same provide a reciprocal action on the sensor when the resulting output does not match the input progress. Okay, next, proposed future. FEOT transfer and future extraction. This research was carried out using the literary study method and a survey of problems found in the Medan City community daily. The research method was carried out by condition location survey. The observation of the one of the well-known hydroponic garden owner in the city of Medan, and there are many types of plants that have been grown through of the hydroponic system. One of them is the hydroponic silly plants, which is have several problems in their maintenance, where the hydroponic silly plants themselves have to do very extra care to get good and abundant crops. The states of this research include a literary study and observational survey as based on the problems experienced by a fairly large hydroponic silly plantation in the city of Medan. By carrying out the progress of making smart plant tools that have been equipped with several sensors that support to overcome these problems. Furthermore, in this study, testing the tools that have been designed directly on the NFT system hydroponic ceiling plants. The tool design progress used three layers where the layer consists of application, network, and precision. In this stage, a design is carried out, namely a design of a software or hardware. The expected output at this stage is to obtain a hardware design, both a circuit block diagram based on the electronic components that have been obtained and software design obtained is accordance with the flow that has been made. The following is a block diagram of the system and 3D tool design based on figure 1. Okay, next, in the picture above, you can see the working principle of the ESP32 cam sensor, which function as a monitor of the NFT system hydroponic silly plants. The function of the ESP32 cam is that it used to get an overview of silly condition in real time, so that the silly plants can be monitored in real time through an application. Okay. In addition, there is an EHG sensor that is used to check the ppm value easily plans digitally and integrate via the internet, which is controlled automatically. And there is a relay as a switch to turn on the turn off the spray nozzle connection to the pump. The 3D design aims to describe the layout of the tools to be installed in the NFT hydroponic system. The tool design progress will use 3 buckets of water. An explanation of the first bucket containing vegetable pesticide in which is there is a water pump, and the second bucket containing water flowing into the pipe of the NFT hydroponic system. And third bucket contain AB mixed nutrients that have been paired with ESA sensor. With when the ESA sensor detect the ppm value, the second bucket is small or experimentally 500 ppm. The DC pump the third pipe will automatically add nutrients into the second bucket slowly until the nutrients in the second bucket result more than 700 and less equal 1500 ppm. Okay, next. For Furthermore, the design of the tool is carved out so that the growth of silly plants can be monitored from a very long distance and the maintenance is controlled from a very long distance. It is this application that provides maximum silly yields and makes it easy for hydroponic silly farmers to carry out maintenance only via mobile phones. Monitoring and controlling silly plants can be done anywhere and anytime without any time limit while there is still a smooth internet network. The following is the design of a three-layer architecture circuit and wheel based on figure 2. Uh, okay, can be seen from the table. Image below. In the design this tool, three layers IoT architecture is used with application, network, and perception. The application itself uses the Blink IoT application, which has several features such as a live broadcast screen feature integrated via the ESP32 cam sensor, a push button to activate the spray or spraying pesticide on the plants digitally, and cow, which displays the ppm value of water integrate with the EC sensor. Then the electronic circuit schematic in the design of electronic circuit in this system is that an application is needed that is able to describe the components of the system, so that from the application and load with availability of all the components needed, the freezing application is used. Okay, next data and experimental setup. Tool testing is carried on daily based on components and sensor used can work based on the reliability of the tool to be used. Then testing the integrate ESP 8266 microcontroller with the I am getting the target ppm value and achieving the ppm nutrition value in the hydroponic silage plants. To see the result of testing the ESP 8266 sensor and microcontroller which have been operation when they reach the time specified in the test based on table. Okay, can be seen from the table starting giving nutrition from day 5 and start the growth progress. Okay, next result and discussion regarding the implementation of the tool with the concept of building an IoT architecture using 3-layer with constraints ESP 32 cam sensor, which is used for monitoring hydroponic silage plants. In addition, there is an electrical conductivity or EC sensor that is used to check the ppm value of nutrients in water, as well as a nozzle spray that is used to spray pesticide directly on hydroponic silage plants. The hardware sensor is integrated though the not MCU ESP 8266 microcontroller, which will be connection to a Play Store application which can be downloaded directly for free. The application is Blink IoT. To monitor and control through the network or internet network in real time, so that the result of making this tool maintenance and control of the hydroponic silage plants with the NFT system are well realized even though the farmer are very far away, can be seen in the image below. Node space tools, TGS sensor display, monitor sensor display, and ESP 8266 display. Okay, next output. Figure 3, overview of the tool. In the tests that have been carried out at this stage, the aim is to describe the result that have been obtained using the ESP 8266 microcontroller and sensor that have been installed when the tester research and the specific time. Okay, conclusion. Based on the result of the research that has been done, it can be included that monitoring and controlling silage plants using the ESP 8266 microcontroller and ESP32 cam sensor. ET sensor relay and set nozzle makes it easy for farmers to carry out maintenance only, even though the farmer is very far away. By spraying pesticide regularly, which is 2 times a day, you can prevent caterpillar pest attack on silly leaf. Therefore, by installing a nozzle that is integrated by the relay and ESP 8266 as a control, pesticide irrigation can be done digitally using the Blink application. implementing the tool by using the TDS sensor on chili plants with the NFT hydroponic system. Farmer can find out what the ppm value is contained in the water and don't need to add nutrients directly to the plants. Adding nutrients automatically through a pump located in the water reservoir can maintain the ppm value at the desired value position. The relay itself, it used an electric switch that function to disconnect from the electricity supply to the spray nozzle and nutrient pump. Okay, acknowledgements. Thank you to Kemendikbudristek for funding support for publication through the Student Creativity Program or PKM in 2022 and full support from the Electrical Engineering Study Program at an area university. Okay, that's all my presentation this time. If there are mistakes, I apologize. I say goodbye. Thank you.